All right. Hello for anyone who may be watching here. We're getting started with some live view astronomy tonight, as anytime you take your telescope out, or at least anytime I take my telescope out, it's pretty likely that there's going to be a couple of issues here and there. So I've been just working through a couple of those, as it looks like I may be slightly off my first target. Let me get that framed up before I switch it over here. One moment. All right, let's go ahead and at least try to get started here. We may need to skip my first target for a little bit here, but that is okay. So let me go ahead and get one thing moving. Hi everyone, welcome back. For another attempt at a live view session. It looks like I'm successfully streaming this time to what I meant to be streaming to, which is great. Now we'll see if beyond my computer, if my other equipment can work. So what I thought we'd do tonight is try to take a look at some of the different objects that are out there and up this evening. Unfortunately, it's a full moon, which typically means that a lot of times there may not be as much detail that you can get underneath a full moon that you might get otherwise. But we're not going to let that stop us. You can still see some stuff out there. May not get the best picture in the world, but that's not what we're going for tonight. We're going for finding objects, looking at them, and making sure that things are, and really seeing what we can see out there, really, more than anything else. The one thing I was trying to do at the beginning of this was get the moon to come up itself. That's proving to be a little bit more difficult than I thought. I think my alignment may be slightly off on that, but that's okay. Once we get through a couple of the targets I wanted to get through here, I can certainly hop outside for a minute and do this. So centered on my first target, and I'm going to go ahead and switch over to our live view software here. And once I have that up and running, okay. And let's start off with a 15-second shot at our gain of 350, which is a pretty high gain setting. That's kind of trying to amplify the signal that's coming in as much as we can. And we're going to see what we end up with here. All right, there we go. So we have a picture of some stars. That's great. But didn't we want to see a little bit more? Yep, we sure did. So what we're going to do now is we're going to go ahead and turn on our live stacking capability. And this is where, if you've watched any of my previous videos, each image that comes in, we automatically kind of stack to average out a lot of the noise and let us be able to kind of stretch that image, look a little bit deeper into it, and see what we can find. And already with 2 frames in there, you can start seeing, hey, there's definitely something there. And what we're looking at here is the Triangulum galaxy. So this is one of the larger and brighter galaxies in our sky outside of Andromeda. And this time of year, it's kind of almost directly overhead around this time of night. And what I'm going to do here is slide it down, try to make that background a little bit darker. And so let's zoom in just a little bit. So definitely a little grainy, but starting to get a picture there. Let's take that there. And so you can actually see a little bit of the spiral arms kind of coming out here, and that's the core there. Some of the fun things about the Triangulum galaxy is that it has a lot of nebulosity in it, a lot of nebulas in it. And one of the really interesting things here is looking at this, you'd say, okay, I got a lot of stars around here all over the place and kind of a fuzzy galaxy there. Well, this guy right here, if you notice, it's not round like the other stars. This is actually a nebula in the Triangulum galaxy. It's a nebula that, if you were looking at some of the other nebulas that we typically look at, like the Orion nebulas, would be several times the size of that. It's absolutely huge. So it's so big that you can actually easily see it as its own object from a whole other galaxy away, which, in my opinion, is just kind of amazing that's the possibility there. And some people with telescopes that zoom in a little bit more than mine will actually do some close-up images of just that zone, just like they would any other nebula, which is pretty crazy. So we're about 11 frames stacked in on this. One of the things that I wanted to do here is set up a dark file, a dark folder, sorry, not dark folder, a dark frame. I'm going to change this to 30-second exposures. Let's go ahead and grab the dark frame for that. And I'll apply a flat frame that I took earlier this evening. Let's see if that gets us a little bit better picture. Alright, so we're going to go ahead and clear this out and start over with a 30-second frame here. And that should get us a little bit more detail than what we had before. Well, that definitely blew out, right? Because it's a little bit longer frame. So let's go ahead and let's reset all of this back to our defaults. And you can tell this is very blue here. One of the reasons for that is I'm using a little bit different filter. It's supposed to keep some more of the natural sky color in. And then two is when you're under a full moon, your sky ends up being extra blue, right? So we're a little extra blue tonight. Now that we've got 2 frames in, let's go ahead and re-auto stretch this, recolor balance things, and let's see what we've got now. All right. Yeah, there we go, there we go. All right. So now we'll let this build up for a couple of minutes here and see what kind of additional detail we can get in on this. Taking a listen, it sounds like my music may have been a little bit louder than what I meant for it to be, so I went ahead and just tried to do a little bit of a turn down there. We'll see if that makes a little bit of a difference. All right, so here we are, about 3 minutes in, and boy, you can really start to see this detail starting to come out now. So I can definitely tell that we've got a galaxy there, and we've still got our big nebula that I was referring to there. I believe also this kind of little area here is also some. Oh, sorry, I'm probably not clicked in on it for you to be able to see my mouse. Sorry. So this kind of little nebula up here. You know, I think a little bit more there as well as a different nebula area. And now, obviously, if you're going to, shoot these for the best possible quality, you're going to want to take really long exposure times. But we're just trying to get an idea of what we've got out there. And so far, I feel like we're already starting to see some good results there. Let's see. Surround with this just a little bit. head down. Oh, come on. There we go. Now we're starting to look a lot more like a natural kind of color there. Zoom out just to see. It looks like that flat frame is doing a decent job here. So this is kind of on our whole field here, really looking at this galaxy. And now you can really see how his arms kind of come out way to the different sides. So very, very cool there. Now I've also set this up so that I've got the chat open. So if anybody joins and wants to chat with me, feel free to you know, submit your chat message, and I should see it on about a 15-second delay. Otherwise, this is after the fact. Feel free to leave a comment. You know, happy to answer any of these. All right, so this has been going for 7 minutes now, and we've really got some good detail in there. Now, I've got one last little magic trick I can do here. So you can see, as I was talking about, this is really starting to look like a nebula instead of a nice round star, right? So is this area up there. You can start seeing a lot of those dust lanes and things. But it's still not, you know, it could be better, right? Well, there's a few tools we have in here to help with that. First one is being able to do what's called deconvolution. It's kind of almost like putting a pair of eyeglasses on top of this to sharpen things up. But at the same point in time, it adds a lot of noise. So what I typically do is I'll add in this deconvolution and add in a filter on noise reduction at the same time. So I'm going to click these both on. It's going to take a second. And it might be, when you're looking at this on YouTube, a little bit hard to first tell. But it really does sharpen things up quite a bit if you jump back and forth and look at it. So let's go ahead and turn on the deconvolution, and boom, things kind of got a lot noisier around there. But once I have that filter on as well, it's actually, in my opinion, a little bit better image. So what we're going to do is I'm going to turn that off just so we can kind of see the difference again. So I'm going to turn off, that's without the deconvolution, and that's with it. So it just adds a little bit more definition and detail into the pieces that we're looking at. And I'll go ahead and leave that on there. I don't normally have this on at the beginning because it just slows things down. So it's normally good to add on once you have kind of an image that's in pretty good shape. But one thing is, let's really bump up the zoom in here. I'd like to take a look. So there's that nebula that we were talking about there. Now this is obviously just a few pixels, not something that's really worth zooming in an extreme amount with this particular telescope, but just crazy the fact that you could see these nebulas at all, an entire galaxy away. Just really, really cool to me. back out. And there is our Triangulum galaxy on our background field. Looking pretty good. So I'm going to go ahead and save this particular guy here. Wait for the next frame. We'll get a little snapshot out of that. Just want to double check how that looked. Yep. There's our final image. All right. So let's jump back over here. So we're done with this guy. So we're going to turn off our live stack. And as a matter of fact, I'm going to go ahead and turn off the camera as well there, because I want to try to move to our next target. So we'd take a look at the Pleiades. Oh, I need to connect my camera here first, or else it won't be able to see anything. And so this is a tool called Sequence Generator Pro. For anyone just starting out, this is way past what you would want to mess with. But one of the things I like about it is that it uses plate solving when it controls the telescope. So what that does is I can give it a particular object name. It'll move the telescope over there. And normally any telescope will probably be off by a little bit. And so what it does is it then does what's called this plate solving, where it matches the picture it takes against a database, and in this case it can tell it's 93 pixels off from where I wanted it to be in the camera. So it'll move the telescope a little bit, go ahead and capture a new picture, scan it again, and it says it's 4 pixels off now. Well, 4 pixels is much better. That's exactly where we want to be. So the reason why I don't stay in this one the whole time is it doesn't let me do live stacking, and everything's in black and white. So not super helpful for what we're looking at, but really great for making sure that I get where I want to be. So let's go ahead and jump back in here now. And we're going to be looking at the Pleiades. So the Pleiades is a star cluster out near Orion. If you guys have ever looked and seen what kind of looks like a very tiny Little Dipper, out near Orion, that's the Pleiades cluster. And so it kind of looks like a Little Dipper, but it actually has a lot of stars in it. Its common name is the Seven Sisters. Let me go ahead and zoom out here. And was named by that based off of the number of stars that you would be able to see with your naked eye. Actually, back when the ancient Greeks were doing astronomy, the Pleiades star cluster was essentially the eye test of the land. So, like we might look at a chart and try to read letters of different sizes, they would have people look up at the Pleiades cluster and tell them how many stars they could make out. So if you could make out 5, maybe your eyesight was okay. At best, if you could make out 7 or 8 of them, then your eyesight was in pretty great shape. So once again, we're aligning these up. Why did my flat frame stop applying? Let's go ahead and get that in there. And the interesting thing about the Pleiades is a lot of times when you look at something that looks like a constellation, it's kind of an optical illusion. The stars are wildly differently away from Earth and that kind of thing. But for the Pleiades, this is an actual star cluster of all pretty young stars. They're all very blue in their appearance. Kind of hard to see and hear because honestly, even a blue star a lot of times appears kind of white, especially when it's this big. But the interesting thing about them is because they're all in a very kind of tight area, there's still a lot of nebulosity between those stars that they all formed out of. And that's what we're seeing here. This isn't noise, this is actual nebula around it. So let me kind of come in here a little bit on some of these. Oop, maybe that's a little too far. Let's go to this far. So looking here and here, these kind of wispy bits coming off, that's all nebula around these stars that that formed out of that gas. And you know, for any of my previous videos, you may have noticed that a lot of nebulas tend to be red. This one's actually much more of a blue one, which is you know, mainly that there's a lot of oxygen in this nebula. Oh, meant to go the other way with that. Sorry. So there we go. So now, a few frames in, we're really starting to see between the large 4 stars here, a lot of that kind of nebulosity kind of starting to come in. Let me see if this. Like to, let me take the red down one more. Oh, maybe that's. Oh, I know why. I still have my enhancements on. I told you it tends to slow things down when we do that. So let me take this off. There we go. That's a lot faster. Oh. I find I'm always one slight tick off of where I want it to be for color, and I always shoot past it. There we go. This is a lot more of having kind of the blue that tends to be in this area in here. You can see there's nebulosity all through this region. The tricky part about being able to pull it up in longer photos is that these stars are so bright, right? So it's always a balancing act between being able to see the nebula well without these stars becoming so bright that they just overwhelm everything else in your photo. So now that we have this going on, let's go ahead now and put our sharpeners and things back on. And there we go. So now we can see a little bit more of this detail coming in. So this is zooming all the way out to take a look at this whole region. So this all here, this is all additional nebulosity gas. Not, you know, when I first took a picture of this, I thought this was just some weird noise I had in the image. And nope, it kind of goes from this brighter kind of blue into a more muted kind of non-blue color over there. So it's almost like someone had these stars and then took a little paintbrush right across them. I'm going to let this run for a couple more minutes before we move on to our next target. right, so there we are, 10 minutes 30 seconds in, and really starting to see a lot there. It's a lot over what we originally had in here. There's almost like wind or clouds kind of coming over the sun, looking at that. A lot of detail coming off there. I think that looks really nice. Let's turn off some of our stuff here just for a final play with the histogram. Darken our background up a little bit. Oh, there we go. There we go. All right. So now when we look at this, there we go. Now we're really seeing lot more in there. Seeing how all of these kind of connect in together, coming down into the other pieces down here. All part of one stellar nursery, and they've said over the next, I forget what it is, several million years, these stars are going to start drifting out in different directions, and they'll just be different stars out in the galaxy. But for right now, we still have the Pleiades star cluster. So let's go ahead and do what we did before here. Let's go ahead and save PNG, what this looks like. That sure looks good, doesn't it? Here's a nice piece for your desktop background, that kind of thing. And that's without hours and hours of additional work. Just 10 minutes of looking at it. Pretty neat. So, jump out of this. All right, so what should we look at next? Let's see. Let's go ahead and close this camera for now. And all right, in honor of Christmas, I thought we might take a look at the Cone Nebula. Now, why would the Cone Nebula be in honor of Christmas, you might ask? Because the Cone Nebula is actually the top, or the bottom, or the side, depending on how you look at it, of a particular cluster and nebula complex that's called the Christmas tree cluster. And so once we pull this up here and let it run for a little bit, I haven't tried it with this particular filter, but we're going to see, and hopefully we'll be able to kind of make out what they're talking about with that there. Let's see. Hoping we're not too close to the moon for this, but we'll see. What you guys aren't seeing is on my iPad, I'm kind of watching the reticle move, so I have an idea of where my telescope's pointing at any given direction here. Well, looks like from that quick little frame there, we're at least seeing some stars. Let's see how far off we are, though. Oh, only 4,000 pixels, 4,400 pixels. That's off by a little bit. Let's get in the right spot. This is what I love about this automated kind of targeting process. All right, Let's see where we are now. All right, it matched it. Now we're 8 pixels off. Much, much better. All right, so now let's jump back over to SharpCap and let's see what we've got. So we'll leave this at 30 seconds and 350 again. Go ahead and clear the stack. Let's reset everything. And let's see what we can see. Here comes our first frame, and it's blue. Surprise, surprise, surprise. Now we are a lot closer to the moon on this shot, so if you may have noticed in the other ones it was a little blue, this one is a lot blue. So hopefully once we get a couple of shots in here though, we'll be able to kind of move past that with some good color balance. Now we're 2 in. Oh boy, we really may have to turn down our time here. Let's see. We're getting to. All right. Now there's definitely some detail in there, but I think we might be losing a lot of it based on how long at this this level we're going. So we're going to go ahead and reset everything here, and instead of 30 seconds at 350, we're going to cook this turkey a little bit less and go 30 seconds at 250. Let's get the right dark frame for that. For some reason it always wants to take the flat frame away, but we're going to go ahead and do that. Let's clear it up. Yeah, this is definitely that extra light from the moon. It, you know, it just adds more to my red, green, and blue peak, and if we're pushed over this far, a lot of that detail just goes to white or gets lost in noise. So kind of wait for 2 of these to come in for it to readjust the stack and show us where those histogram peaks are. But this is already not anywhere near as kind of blown out in the blue as it was before, so feeling a little bit better about this one. All right, 2 frames in. Okay, yeah, this is a lot more like our other images. So let's go ahead and put our stretch in, our auto color. All right, and so we can see something's going on in here. Let's see if we can zoom in and take a little bit better look. Maybe not quite yet. Unfortunately, I know what I'm looking at here. You guys don't, so I'm waiting to make sure that that we actually have stuff kind of coming out the way we would want it to before we talk about it too much. So we're 4 in here. I'll let you know we're looking at the right thing. The question is whether or not it's too washed out to make out what we're really looking at here. I'm going to give it another minute before I kind of make that call. Yep, let's... Yeah, we may be a little bit more washed out than we'd like to really make this out in a lot of detail. But this is the Christmas tree cluster here in this range. The Cone Nebula, unfortunately, isn't really quite coming in very well at the moment. That's actually kind of right over here. But I think, unfortunately, we may just be a little too dim for a lot of that to be coming through well at the moment. Now, one thing that we can try, let's go ahead and flip this about another way. Let's go ahead and we're just going to do a single image using our 122nd, let's see, using a 2-minute exposure here, so. Go ahead and clear this stack out. We're going to let this run for just 2 minutes, all on its own. Matter of fact, we'll even turn off live stack here. Oh, we may as well leave it on. But we will go ahead and reset everything here. So we're going to give this the best shot, best possible shot for getting as much detail as we can, which is definitely a longer exposure. As a matter of fact, in order to do this right, let me go ahead and, oh goodness, wow. Yeah, okay, I can tell why right now looking at my guide camera why we're having trouble with this one. That's glare from the moon right there, making it very hard, but apparently not impossible to pick a guide star. But I'm going to pick one myself. So we've got about 30 seconds left on this. And we'll see if we're just overwhelmed by the moon, unfortunately. Three, two, one. Merry Christmas. All right, so let's color adjustment there. Let's bring these levels up. And let's see if we were able to pull any detail out there. I'm just narrow slicing it, but unfortunately I think this may be about as good as we get, unfortunately. So you'll just kind of have to imagine the tree shape here, unfortunately. But it's something that as the moon hasn't been as much in my face, earlier this month I was taking some nice images of that I'm still working on our final processing on. We'll let this finish out for the 45 seconds that it's got here for the second image. See if that second one adding to this helps it out anymore. Alright, so let's go ahead and reset everything here. Got our color balance in there. Yeah, unfortunately, this guy I think is just too close to the moon. All of this glow here is the moon starting to creep in, and that just washes out your dark, which is really what you need for this nebula. So we'll come back and take a look at that another time. Let's go ahead and reset everything out. Oh yeah, super bright there. But let us move on to the next target here. Now, the next one we're going to do here is one of my all-time favorites, and even with the moon up, assuming the moon isn't directly in front of it, we should be able to see it, and that's the Orion Nebula. It's a favorite of astrophotographers for a couple of reasons. Once again, got to connect my camera. And let's go ahead and center on it. So it's a favorite of astrophotographers and astronomers for a few reasons. One, even with a pair of binoculars, you can see this sky. As a matter of fact, it's also a naked eye object. You know, when you are looking at Orion, and let me, while it's pulling this up. The constellation Orion, let me pull it up here just so that, oh, Wikipedia, of course, has like a very academic view. When you're looking at the constellation Orion, right, everyone's used to Orion's belt. You've got Betelgeuse up at the top here and the other stars making up kind of that core area. And then you have the three stars of what they call the dagger. If you notice in this picture, which is a longer exposure one, these kind of blur out a little bit more. And that's because the Orion Nebula is actually that center star. What you would think of as a star is actually a nebula. And it's bright enough that it seems like a star when we look at it, which is, you know, pretty neat in and of itself. So what does that actually look like to you when you zoom it in? So let's go ahead, and now that we've centered on it, let's connect our camera in here again. Instead of 2 minutes, because we don't even need that, shoot, let's start with 4 seconds at our low gain setting. And I'm going to turn off live stack. With this right here, you can see I see a few stars, and then I see there's some blurry there. Even at 4 seconds with very low gain, I'm already seeing details. So let's put that onto our high gain here and see what difference that makes. Hey, there we go. Wow, right off the bat, right? I'm starting to see nebula. Now, when I first started in this hobby, this picture right now is actually probably better than the very first picture of the Orion Nebula that I ever took. And so I was over the moon with this. Now, I'll let you know, based off of the way that we normally look at this, I can tell you this is kind of backwards from the way we normally see it. So I'm going to flip it both ways. And once that next picture comes in, there we go. So gone ahead and flipped this around to the way that makes a little bit more sense for the way that if you ever look at this in other pictures, it ends up looking. So this is kind of the beginning there. You go, Orion Nebula. Okay, fantastic. And actually, believe it or not, once you stretch out, hey, there's more there. But let's start with it unstretched here for a reason. That's the center area here. And I'm actually going to bring this down to about 2 seconds. And the reason why is if, down at this level, you can see there's actually, it's not just a bright spot, it's several small stars in here. Let me zoom in even more. This is actually 1, 2, 3, 4 stars. And it's called the trapezium. And this is one of the things that makes the Orion Nebula kind of a challenge. Because in general, if you're taking an image of this, you want to be able to get it where you see these 4 stars as 4 separate stars, right? So in this case, I'm having a hard time doing that until I get down to about a half-second exposure with my 350 gain, right? So, really being able to visualize these 4 out, and you can see at this point I can start to see the atmosphere move, image to image pretty easily. So being able to see the 4 of those is kind of tough. But the reason why is that this, we talked about the Pleiades cluster earlier as being stars that kind of came out of the same set of gas. Well, Orion is even more so. The Orion Nebula is a stellar nursery. So these 4 stars are brand new kind of baby stars that formed in this area with the gas around here. And so they are extremely bright, extremely hot, and they're lighting up the area around it like crazy. So as soon as you kind of start taking images, as I said before, this right here, this whole bright area here seems like one star to us when you just look up at Orion with the naked eye. But it's actually a whole stellar formation region. So let's go ahead, take this back up to our 4 seconds. Once we do that, we'll be seeing a little bit more. So there we go. Got some good stuff going on there, and that's great, right? This is why everyone loves the Orion Nebula. No. Oh, by the way, you see, looks like a little satellite, or maybe even an asteroid going through. Probably a satellite more than anything else if it's got a streak like that. But that's a satellite going through our picture. So why does everybody love this so much? What makes it so great? Well, this is what you can take real quick. I mean, a 4-second exposure, right? As long as your camera is steady, and pointed at one thing, you don't even need a mount to track it in order to get that picture. What makes Orion great is that there's a lot that you can take this on your first night out with a camera looking at the sky, but there's always more to come back to in Orion. So let's bump this up. Let's go from 4 seconds to 15 seconds, and we'll go ahead and turn on our live stack here. So let's see what comes back at 15 seconds. Doing that, get that music going again. All right, so we've got our first frame in. Probably, oh, sorry, I had it on pause. Let's unpause this. There's our first frame. And by the way, if you notice these streaks here, I noticed something similar last night. It's a group of satellites all coming by at once. So we'll probably see them streak again in the next set of photos. See a little bit longer, and they'll go through. But you can see now already, and I haven't tweaked anything else out here. This is just the raw image coming out. There's definitely some more here, right? This is all blown out very bright, but I see some stuff there, see some stuff there. Well, what happens once let's set the color balance first. Okay. Oh, definitely see some more stuff there. So let's then go ahead and do our stretch in here. Whoa! And this is where Orion starts to get really, really cool. The Orion Nebula extends really far. We're relatively close to it in the sky. So being a pretty small, region there, that those 4 stars they're in, it extends around with a ridiculous amount of nebulosity around it. So even just the auto stretch on Orion reveals a lot. But once kind of start bringing in some more, we just let it run here. But so now let's really zoom in and start to take a look at this. So this was the area that we were looking at before. Those were those 4 stars. The trapezium is now just kind of all blown out to white. But just look at how much more there is in terms of the dust lanes here. Additional nebulas around this younger star that have formed. And just, that just stark color difference between the different elements of hydrogen and probably some oxygen and other dust, within that nebula. And just that idea of almost like flame kind of blowing out from here. You can see it continues up into this area here and all around. Let me zoom back out. And so this nebula actually comes all the way around, kind of almost like, as one of my coworkers described it, a blowfish. All the way around here. This is looking very washed out because that's the direction of the moon tonight. But so this is one of the true stars of the night sky, and no pun intended, but true gems out there for photographers, because it's one of those things that, you kind of can't beat this, in terms of just the level of pretty that you get for the effort and time that you put into it. This is 3 minutes, right? And look at all of this detail around here and all of that. Just gorgeous for just a few minutes worth of effort there. It looks like it was painted, right? It looks like an artist's rendition. But this is something that's really great to focus on. But there's also something else here. Like I said, there's always more in the Orion Nebula to look at. And one of those is what's next to it right over here. And that's this additional nebula right in here. And this is called the Running Man Nebula. Maybe kind of hard to see it, but if you think about turning your head sideways, there's a little stick figure guy here. You can see a little round head, an arm, a body, a leg, and a leg, like he's running along. And so this one's called the Running Man, and is one of those things where anytime folks start taking pictures of Orion, the thing is, okay, can I get the Running Man too, right? Not just because of framing and trying to make everything look pretty and that kind of thing, but obviously this looks a lot dimmer, right? So, question is, like, how deep were you able to get into the nebulosity and things like that? Helps by also looking at how much of this nebula were you able to see. Now, we're 4 minutes in, just coming back over to this after looking at the Running Man for a little while. It feels like we've gotten a lot more detail out of this. Looking up at the top here, right, you can really see how that's extending out there. You can see how this comes around and curves back very gently. You can see that under darker skies or under a specific filter, just looking for, say, the hydrogen data, you'd really see that a lot more. But But once again, we're not done yet. We haven't messed with those enhancements yet. So let's take a look at that. Let's go ahead and add in our 2 tick boxes that we were doing before, and let's see what that does. Oh, wow. That really gave some more depth in there, in my opinion. Take a look at, just the star color differences from the whites to the blues, the oranges and reds. Very, very nice. I'm going to turn this off for a second for messing around with the histogram just a little bit more. Bring blue up a tick or 2. There we go. Bring that in. Oh, that's why I was being a little slow. Okay. And then let's bring that black in a little more. Don't want to bring it in too much because this whole area, if we look down here, and this is where, once again, there's more to see. If you see this dust start to trail off into here, it may kind of look like, okay, maybe the frame isn't all that flat or whatnot. No, really what it is that this whole region is just saturated with dust, So as much as you get, they talk about getting deeper in here, getting deeper on the outside, it just becomes like an oil painting all the way across. So, but for now, let's turn our enhancements back on. I think this is probably about as deep as we're going to be able to go, given the moon and everything like that. But let's jump all the way back out. And now I think it's pretty easy to tell why this is such an inviting target for anyone getting into the hobby of astrophotography. But for even just visual observation, right? If you come out with just a moderately sized telescope or even binoculars, you'll be able to make out this area of it pretty well. You won't be able to tell the color because unfortunately just isn't enough light hitting your eyes to trigger your color receptors, but you'll be able to kind of make out this shape. You'll be able to see it even under normal kind of city skies, that kind of thing. So it really is one of the best starting targets for anyone. And just as a reminder for anyone looking for it, in the constellation of Orion, you get the 3 stars of Orion's belt, and then you get kind of what appears to be 3 stars of the dagger in Orion. The middle one there, if you start to really look at it, even just with the naked eye, you'll notice it feels a little fuzzier, and that's because you're really looking at this here. So, pretty neat what you can see there. Let this run for probably another 2 minutes before we kind of finish out and take our final photo on this one. All right, so we've hit our 10-minute mark here. Let's give it one last zoom in. Not going to really adjust anything else, but just kind of take that big zoom in to really kind of take that last long look at some of the pieces of this. Look at that, just little wisps coming off of this. It's almost like, you know, smoke and water. But think about this across a light year, several light years or more. And then there's our running man doing his best to keep moving. The Great Orion Nebula, as it's called, or as my coworker called it, the Great Sky Blowfish. So why don't we go ahead and make our way out here. We'll save this one. These are just 15-second frames. You know, which means that can be done with any point and shoot, you know, DSLR camera that you might have. 15 seconds is enough where you probably want a little bit of a tracking mount for it, but you know, that's something that could be gotten for 150, maybe $200, and you could be taking some pictures like this. Not too shabby. I think it said it saved it. Let's double check. Let's see, 11:15 p.m. Yep, there we are. There's our final Orion for tonight. Dang you, moon. So let's go ahead and close you up. Turn off our live stacking here. And sadly, go back to a single frame. Let's see what it looks like before we move off. Our single frame. You know, what a difference to, you know, just a little bit of time with it will make there. So now I want to take this back down to kind of that 2-second mark. I'm going to try something. May not work here. See, we're starting to move away now. Trying to control this with my iPad and see if it ends up where I wanted it to end up. Well, it's very white. That's a good start. Let's see what we can do. Less time. Oh, geez. I think I'm on what I want to find. Finally, this is what I was having trouble with earlier. So, yeah, we're looking at the sun in the middle of the night, right? Now, we have found, if we bring this down enough, we have found the moon. Hello, moon. There we go. So, you do not need high gain for the moon. Not at all. Matter of fact, you don't need any gain for the moon. This is right now 3 milliseconds. Gets me quite enough to get started with here. So let's go ahead and let's take it up to a robust long exposure of about 8.5 milliseconds. And here we are with the moon. Let's go ahead and bring that in. There we go. So this is what was causing us so much trouble tonight, but it was also one of the main reasons why I wanted to do the live stream tonight is we have a really nice full moon out there tonight to look at. So this is pretty much exactly what you'd see looking up at the sky right now, but you know, obviously with the telescope you can zoom in a little bit more. So one of the nice things with that you get with a dedicated astronomy camera over a point and shoot is, as I mentioned, these are 8.3 millisecond shots, right? But it doesn't have to take it and save it, take it and save it. It can kind of just buffer them through to the computer as it gets them. And we're not saving these right now, we're just looking at them. So if you look down here, I'm running 13 frames a second, you know, showing up on the screen here. So this is essentially live. You know, it's just about as good as, you know, the Snork's animation was, you know, in terms of frame rate per second there. If I want to bring this in a little bit more on a region of interest, you don't even need dark frames because our shot is so short. A dark frame really isn't necessary. All right, got a little artifact there. Let's see if we can clear that out. Sorry, just trying to get this centered in. There we go. Now that I've done that, you can see I'm up to 30 frames a second. So now we're looking at it pretty much the way that you would see it in a movie theater, you know, if it was, you know, on a film camera, which is great. You know, I've got a live view of the moon here, which is awesome. Now, what does that mean for anyone who hasn't really looked at the moon through a telescope before? Well, you might be able to tell a little bit now, but when you're looking at the moon, you're looking through, obviously, all of the atmosphere between us and the moon. And, you know, that can be anything from clouds and wind and things like that to just the amount of moisture in the atmosphere. And there's a lot of sky between you and the moon. So what that sky really does, it's not something that you notice anywhere near as much on the deep sky pictures because we're taking a very long exposure. But when you're taking these short exposures, what you'll notice is that the atmosphere is always moving. It's always changing. So it's really like looking at the moon underwater in some ways. It may be kind of hard to tell in this shot because, to be perfectly honest, things are looking much better on this than they did for me last night. But if I zoom in more, start looking at this, you can start to see how things are kind of shimmering and shaking around a little bit here, right? Especially if you look kind of at the corners there. Let's go even a little bit further in. 250. Let's go up to like 400. So now when we look at this, you can really see how this kind of shimmies and shakes around here. And that is that just atmospheric turbulence, just a little bit. Every frame is off a little bit from the frame before. And what that all contributes to is making all of this a little bit blurrier than it would be otherwise, right? And so what you do is you look for nights of what they call especially good seeing, where that disturbance is as low as possible. And tonight actually appears to be a really, really good night. Yes, I'm seeing some wobble around here, but you know, I'm zoomed way in. If I take this back out, that almost looks like a completely steady, still picture, right? Sorry for the little artifacting in there. Oh, did not mean to go that far out. There we go. But, you know, last night, this really did look like it was kind of a boiling kind of picture. So I'm going to do something here that I wasn't planning on doing, but I'm actually going to go ahead and do a quick capture. And you see it says 3,000 frames. In our last pictures we were taking, you know, just a few frames here and there, right? You know, we took maybe 20 or 30 pictures over the course of 10 minutes. With this, I'm going to take 3,000 frames. I mentioned before we were at 30 frames a second. So it's just basically recording this as video, you know, and it actually is using a video file that it's doing to make this out here. So we're at 500 frames already. So this is really kind of the main difference between planetary and lunar photography from when you're looking at deep sky photography. And that's really the number of frames that you end up dealing with. It's still the same basic process. The idea of taking multiple pictures and averaging them out, doing some math on them to get a better image. Except instead of trying to eliminate noise, because a lot of times it isn't so much noise that you have a problem with this. This is not a noisy image. It's the atmospheric turbulence that you want to get rid of, right? So what it does is it'll go through and really look at the edges and the lines and the details that are happening and go from there. So let's see, we're at 2,300, and you know, it'll take us about 2 minutes to get our 3,000 frames. And I'm not going to go through the full processing here. I just am really pleased with how steady the viewing is right now, and I want to record this so that I can process it up tomorrow. All right, and so you see it captured it, 0 dropped, and it went ahead and put that file in there. But let me show you. Let me see if I can show you what this looks like after you go ahead and do that particular processing. This is what I ended up with last night. So you can see between what we're seeing right now and kind of the level of detail that you're getting in there to how much sharper it gets once you process those 3,000 frames. There's just a lot more that can be gotten out there with software. So very, very interesting. But looking at this live, let's take a little bit of a tour. So for folks that like looking at the moon and seeing the objects in it, let's talk about your typical man in the moon. The man in the moon is one of those things that tends to disappear as soon as you start zooming in and messing around with the exposure times. But we'll see what we can do here to see what I can do to kind of bring him back out. So this is kind of a lot of times what we'll see. You see your eye here, your eye there, and your face of the man in the moon there. You know, on especially bright nights, a lot of times that's what you can see. Also, for other cultures, they see other things in the moon. Chinese, if I remember correctly, Chinese mythology has a rabbit, your rabbit head with 2 ears there, who lived on the moon, that kind of thing. And so, and a lot of this is because the moon just seems so bright to us, but by taking it a little bit further than what we can do with our eyes, and really kind of coming in here and messing around with the levels. So I'm just doing this just to try to blow out some contrast. Look at some differences there. Can really start looking like what it is, which is, you know, a whole different world to go and look at. So here, I'm gonna go ahead and just reset that stretch. Let's bring it back to here. All right, so I'll tell you my favorite thing on the moon here. And we're gonna zoom in a bit. Bit more. There we go. So I always love the edges, first of all. Those are always one of my favorite things, because the edges is where you start to see your shadows a lot of times. Now with the full moon, you don't get a whole lot of shadow, obviously, because the sun's shining across all of it. But when you're looking at more crescent moons, half moons, wherever that terminator of light to dark is, you get a lot of shadow in all the craters. But the edges are always really cool all the way around. What you'll notice is, depending on the shadows and things like that, but also depending on what part of the moon it is, you'll see a lot more kind of up and down, just wherever the craters happen to be. But I have a particular favorite feature on the moon, and that is this guy right here. This is Tycho crater. For any of those that know me personally, I have a cat named Tycho, who's my favorite little boy, other than my son. And Tycho crater is definitely my favorite crater on the moon, for a few reasons. One, it's super bright. It's about the brightest object on the moon itself. When looking around here, that isn't super tiny. If you look real close with your naked eye, you can even see it from the ground here. But also, it just really shows what happens when a meteor or an asteroid hits the moon, right? You look at this crater here, and then you can just see the streaks of what's called the ejecta, when all of that dust and material that essentially got blown out and thrown off into the rest of the moon, and then came down to settle in. Just a huge impact that went on there. So one of my favorites. I love coming back to it. This particular telescope is made, I have it more for a little bit wide field stuff, so even zoomed in, there's only so much detail that I can pull out of it from here. But as you can see, there's just more and more light and dark in here. I mean, now that we're at getting upwards of the 400 on this, we're starting to hit a little bit more of the seeing limit, but really not much. Boy, this really is a steady night. But you can see here a little bit of the dark ring in there. Let me see if I can have that start to come up. Yeah. So, when these impacts happen, they throw out dust and debris out to the sides here, right? But it's kind of like if you ever watch a drop of water or fall down into a pool of water. There's a big splash that comes out to the side, and there's also one drop that falls right back in the center. And it's just the physics of an impact like this, where, and you'll see it looking at these other craters. There's a lighter spot in the center where a certain amount of it just went straight up and came straight back down again. Versus there was, for anything that was off at an angle, it ended up going further out. So really, it's kind of an interesting thing there. But this is one of those areas, kind of like Orion. You can come back to it and see more and more detail over time there. So really, really love that area. Zooming back out. Not go into the whole thing here, but you'll notice on the moon, we can see this obviously from the ground, there's lighter areas and darker areas, right? It's really easy to think of the moon as being just so bright, especially when it's a full moon. I mean, it really is bright. And if you look through a telescope, at the moon, sometimes you want to put just some filters on it, not for detail, but just to tone it down a bit. Moon, right? It's really, really bright. But the funny thing is, the actual dirt and rocks and dust on the moon are really mainly kind of black. I mean, very dark gray. It's really just the fact that there is so much sunlight hitting the moon, and there's no atmosphere to kind of scatter it away or absorb it when it reflects back off, that just a lot of that light does end up reflecting back. Probably a good thing that this isn't a moon made out of ice or something that was a lot more reflective. Otherwise, our nights where we have a full moon might be very, very, very different. But these areas here that are a lot darker are also a lot smoother in general. And this isn't just kind of knowing this from NASA or something like that. If you end up see what we can see when we zoom in here with this scope, but especially when you are looking at it through a telescope that you put a little bit higher magnification on than what I can do with the camera here tonight, you can look in and really see that for the most part these are very, very flat plain areas, and they also, see if we have any of these come in. May just be a little too. Trying to see if I can find any of the cracks. Yeah, maybe it may not be a good enough resolution on this particular setup to be able to see it, but on some of these you'll actually see cracks running through, where essentially what these are is they're ancient lava flows that hardened, back either when the moon was still kind of a little bit more molten, a little bit more geologically active, or in response to one of these meteor impacts caused an eruption, and then that rock hardened and became, what you're looking at here, very, very solid. And then some of them have cracks down it, so think of like concrete cracking. So very smooth. Still with a lot of dust, obviously, and dirt and things like that. But overall, much, much more flat plains than what you'll find in the lighter areas that, have a lot more feature to them. Also, a lot more long-term craters in them, right? That kind of thing. Which shows that these areas, more likely than not, formed a little bit more recently, right? I mean, you have all these craters that are here. Why don't you have craters here? Did something not hit there? Well, no. Just randomly speaking, the same amount of craters should have been hitting in this area that we're hitting in this area, same amount of meteors, that kind of thing. But the difference is this area got wiped clean by the lava flows. These areas did not. So, very kind of interesting. Now, looking at this, you can see that kind of bubbly is starting to come back a lot more here. So I think we may have gotten just kind of lucky on our viewing time when we first started here, which is fantastic. Now, one of my goals over the next few years here is really to catch transits with the moon. And so what that means is, got the moon here, it's up, looks great, but there's 250,000 miles between us and the moon, and we have a lot of junk out there in orbit between us and the moon. And with the right kind of software and tools, you can essentially prep for that. So that, looks like moon's moving slightly down from us. Let's move her back up. So you can plan for that. So one of the things I want to do is I really want to catch an ISS transit. So that's the International Space Station, and there's websites out there that you can sign up for that'll tell you when the ISS is going to be passing overhead, so you can look and watch it go through, and you see it's a very bright spot in the sky moving very, very fast. Well, if you've got the math right on these sites, you can also ask, hey, when is it going to pass over, looking at where my house is, where I'm sitting, when is it going to pass directly between me and the moon? And that doesn't happen often, but when it does, you can actually just be notified. And what I want to do is I want to basically have this set up. As you see, I'm at 30 frames a second right now, even with that thing moving fast, hoping I can catch it right as it's moving across the moon and get some good pictures of the ISS against the moon. So that's one of my goals here for the future. Let's see. So I'm just trying to clear out those little artifacts that are coming in. A little bit of a issue with SharpCap there, but I guess once you use the moon as an eraser once, you've kind of figured out how you want to do it. And I'll go ahead and put this, probably full screen mode was not what I wanted to do for the stream. Sorry. There we go. What I wanted to do here, I think there was an option to put this in a little bit more full screen for you guys. There we go. So a little bit bigger view for you guys there. One of the great things about the moon, in my opinion, is that it's free. You know, you don't need binoculars, you don't need a telescope, you just need your eyes. It's something that I think we take for granted a lot, is that it's up there. Tonight, you know, I was thinking about this stream a little bit, but I wasn't really paying attention. My family and I were driving out to dinner with some friends, and my son, who's about 7, in the back seat, I noticed that the moon up front was really looking, was just up over the horizon, right? And anyone who's looked at that before knows that the moon looks pretty different when it's just up from the horizon. So I pointed to my son and said, "Hey, look, there's the moon," you know? And he just went, "It's so big," right? And was talking about how the colors were different and asking why that was. Oops. Sorry, it looks like my my team viewer crapped out on there for a minute. But that's okay. Let's go ahead and switch back over to this while we're talking. Hopefully I'll get that back up in just a minute there. But, you know, he was talking about it, you know, it was so big, and, you know, why was it a different color, and was it actually bigger when it was down there, right? And just all sorts of questions that I think we've all asked at some point, right? And it, once again, the thing that I loved about it is that's free. That's a free conversation that you get to have, right? When you're talking about the moon, you know, which is just great. It's one of the few objects out there that is, you know, big enough and accessible enough to everybody that you can always just have it be part of what you're talking about. All right, so it looks like I've got this back up. I'll be playing with the screen size for just a second here. All right, there we go. Okay, so now we're back up. For anyone that's wondering, so it's chilly outside. I don't want to sit out there all night. So I actually have a laptop hooked up outside in my backyard to my telescope, and I am doing all of this from the comfort of my office in the house. So nice and toasty warm in here while we look at the sky. So once again, this is live. This is not doing anything with still images or whatnot. We're running at 30 some odd frames a second. One of the ways that we can look at that and kind of confirm is my control of the telescope right here. Right. So I can just start moving the scope around. And you can see how fast it responds on the images here. So really pretty crazy. Yeah. So I think I would like to take, with how stable and how nice this is, let me make sure I'm not going to crap out my storage space, because I know these things can be, okay, I got 38 gigs open, that should be fine. I am going to take another 3,000 frames, because things are just looking too good tonight. But yeah, so I encourage everybody, who's interested in this at all, get excited about the moon. It's one thing I've noticed when talking with various folks that are in this hobby, and I'm guilty of it myself, is it's really easy to sit there and go, okay, yeah, I've taken a few pictures of the moon. I've been there, done that. What else is there? Okay, I gotta go take pictures of Jupiter or Mars, and now I'm moving on to deep sky objects and that kind of thing. And then the moon just becomes something to be annoyed at, right? It's so bright that we couldn't see Orion as well as we wanted to tonight, or the Christmas tree cluster didn't come through. Man, I'll really need to wait until the moon is a new moon or something like that. Got to get that moon out of the way. Well, another way to look at it as, oh man, moon's up tonight, time to shoot the moon, right? Is like the moon is something that's good to come back to. Full moon, sure, it may seem like it looks the same every night, but it doesn't. As that terminator comes through, there's different views of it, different magnifications you can do, and even just looking through binoculars, it's a different view every time you see it. You see something different every time, and it's a whole other planetary body that we can see with our naked eye, right? So encourage you guys, don't overlook Luna. She's there for you. Even on cloudy nights, sometimes you can see the moon, and sometimes even get some better pictures that way. All right, so that was the moon. Let me check one or two other little things here. Okay, that's looking good still. All right, so I was going to try a couple little things here. Let me make sure I'm connected back up. My iPad. All right, so let's say goodbye to the moon as we move on to our next target. Now, we're moving back into deep sky country here, unfortunately. And so 8 milliseconds just isn't gonna cut it anymore. So let's go ahead and bring this back up to a nice 15 with our 350. Add our dark file. And we're back to blue with some stars again, right? Which is fine by me for right now. What we're looking at here is a different nebula, but still in the Orion area. And this is the star Alnitak. Alnitak tends to be kind of like the moon, a star that a lot of astrophotographers kind of hate, because it's a big bright star right next to something that we want to take some pretty pictures of. So let's go ahead and we'll make sure where we are with this. Okay, so we've got a pretty good histogram there. All right, so let's go ahead and turn on our live stacking. all of the stuff that slows us down off. I'm going to say goodbye to Orion. There we go. And let's actually reset all this here. We're going to let it take a couple of frames before we try to take a look at what we've got here. I know we'll be able to see something. The question is how good we'll be able to see anything, but we'll... All right, a couple frames in. Hey, there we go. Now we're seeing some stuff, including a lot of glow from the moon. But what we're looking at here, and it'll be a little hard to tell for the first few frames here, is we're looking at the Horsehead Nebula and the Flame Nebula. So as we stack a few more in here, should start seeing this starting to look a little bit more like what we want. Now, I'll let you know, just ignore all of this part of the frame because this is just all the moon. But let's go ahead and zoom in less than that. Maybe even a little less than that. There we go. And this is the Horsehead Nebula. Now, anyone who's seen some other videos on my channel, you've seen a much better picture of the Horsehead, but we're just looking at what we can look at live here, or close to live. You know, so this is 90 seconds in. And it's just slowly getting better over time there. But while that one's kind of coming in, we also have the Flame Nebula, which is a really cool nebula next to the Horsehead. In addition, we have an additional nebula just kind of peeks out around this star here. And so lots of activity going on in here. And then you have this whole region. This isn't the moon, actually. This is, you know, the hydrogen region out around this the Horsehead is set against. And so a lot of things all going on at the same time here, which is really, really neat. Let's see. I want to try to get some more contrast in here without losing too much detail. There we go. Don't need all of you. There we go. So yeah, so there we go. So you're starting to see that Horsehead kind of start to poke out there as we go through. Let's go ahead and try to put on some of our sharpeners here and see what that does for us. Not a whole lot, unfortunately. We're still dealing with a lot of kind of separation. Horsehead is hard to pull out because it's a dark nebula here, right? So, you know, you can see the red of this and kind of the orange and red of this a lot easier than you can, you know, kind of an absence of color there. But like anything else, it rewards time. So if we left this here for 20, 30 minutes, or better yet, you know, a couple of hours, you'd start seeing more come out. But this is really just kind of the starting point with the fact that we've got so much moon up in our face here this evening. But yeah, we'll let this one run for a minute here. And I'll be back. Well, one, I think I figured out a much better full screen view of this for going forward. I think this looks much nicer. But, you know, this is probably about as good as I think we want to try to get to. You know, if I can see this much glow coming off already, you know, there's only so much detail we're going to be able to pull out of this. And we've got a whole other video on how this can look better over time. So, so why don't we go ahead and try to finish that up. Let's see. I'm trying to figure out how to get my... there we go. So looking at this here, we're at about 3 minutes. Oh, we got to be further along than that. Or do we have live stacking pause? No. Okay. Well, why don't we go ahead and finish that? So we're gonna go ahead and save this guy, just like we have with some of our other pictures as we've gone along. All right. So now I want to, let's go ahead and turn off our live stack. Go ahead and leave that at 15 seconds from now. And we are going to try a very special target here. Maybe having a little bit of camera trouble here. Let's go ahead and do a close on the camera. Take this out of full screen for a minute. Sorry, my camera just didn't seem to want to be sending photos for a minute there. Okay, that looks better. Okay, so we're doing this. Let's come back over to our 15-second photo. May or may not be able to get this tonight, but I'm going to try. Yeah. All right. Well, sorry there. Sometimes the software is a little bit better than other times at tracking these, but I was trying to track Comet 46P, which is out there right now. But fortunately, it does not look like that one is in the cards for us. Let's try a different target here. Just a couple frames a second. So this one's requiring the telescope to really flip around quite a bit, so it may take us a minute before we get over there. Question is whether or not I may need to use my other piece of software to dial in on this. But we'll see what we can get. Oh, no, I think we might have it. By Jove, we might have it. Let's try hitting 30 seconds and see what we can get. Apologize for the white screen here. As I switch over, what it does is it takes what it has so far, which in this case I guess was a very white exposure. There we go. Oop. Oh goodness, did we just hit? Sorry, I think we may have hit something called a meridian flip. Let me jump this back down. Yep, we surely did. So interesting time to bring it up. I can kind of let you know what that is. Meridian flip is you've got two halves of the sky. Telescope kind of tracks on one half, and sooner or later it's gonna, because it's going from east to west, it can kind of bonk into the telescope. So after a certain amount of time, what it does is it goes, okay, this thing has passed the center point directly overhead, and now I need to flip around and look at it from the other direction. And so that's called a meridian flip. And it just so happened when we started looking at this, it was on one side of the meridian, and 20 seconds later it was on the other side. So the scope decided to flip around and look at it a different way. Now, question is whether or not once it did that, it ended up centering on the same thing, which I don't know that it did. So I think I may need to do this. So just so you know, I'll take the suspense factor out of the way. I'm trying to look at the Crab Nebula. And if it doesn't show up in this 30-second, then I'll switch over to my other software and really center it in right. Yep, not seeing it there. Okay, so let's go ahead and close that for now. Jump back over here, reconnect our camera. And this time what we're going to use, this is another nice thing about this, is what they call the framing wizard. And type in, I would like to look at the Crab Nebula. Can you tell me what that looks like, please? So what's going to happen is this software is going to search out. It actually looks at this online, pulls down a database of what that should look like. There we go. And pulls up a little section of that sky. And I can draw a little box and it'll say, hey, this is the size of your camera. Where would you like it to be? And I can say, I want it to be right there. And just say, let's go ahead and center it here. That does the reference. I need to kind of wait for it to finish. There we go. So just center that there, and then what I want to do is just say I'd like to create a sequence. Oh, sorry. Let's put my camera box. I want it to be right in the center there. Say create a sequence, call it Crab, append it onto the end. All right, good. Created one new target. So when I come in here, I can see there's Crab Nebula. And finally, I can tell it to center right there. Obviously, doing this in my iPad is faster, but it's being a little bit less accurate. I still need to work out some bugs on aligning my telescope correctly to the controller that I've got here. But this other piece of software still lets me do stuff relatively quickly. All right, I found that. Once again, hey, we were only off by 4,000 pixels, which means about a frame worth of my camera. That's about how far off we were. So instead of hunting and pecking around for that, we'll just let this guy go ahead and bring us in, hopefully a lot closer. Let's see how much closer. 5 pixels off. There we go. That'll work. So now let's go ahead and jump back. All right. So we've got it at 30 seconds right now with our 350. Turn on live stack. So I'm doing 30 seconds because I really want to see, you know, how much, how deep we can get in there with a particular shot. Because this is a small target, but it does have some good detail in it. Hey, that's real blue, isn't it? Okay. We may be getting washed out once we get there, but we'll... There we go. So if you look, you can see this little fuzzy in there. That's what we're going for. Once we get kind of 2 frames in here, we'll dial it in a little better. All right, 2 frames stacked. All right, there we go. I want to wait for the 3rd frame to come in before I start dialing in too much. All right, so we got our 3rd frame. Let's start bringing that black in. Now, let's go ahead and zoom in quite a bit. Maybe not quite that much of a bit. All right, and that is the Crab Nebula there. Now, this doesn't seem like much, and honestly, for my telescope, this is really pushing it in terms of how small an object I can really look at with the telescope here. But the point on this is, I like this for a few reasons. Mainly, what the Crab Nebula is, and what it really means for us when we're looking at the sky here. So the Crab Nebula is a planetary nebula for the most part. It's actually a supernova. So what that is there's a little star in the center here that exploded. And that star is still there, kind of pumping out light, but it's now a much smaller. I believe it's a white dwarf in there. And what's left of that original star is now blowing out in this expanding ring of debris and gas and elements and things like that. And it isn't, most of the time when we talk about stars, we talk about hydrogen, right, as being the big thing, right? You know, most stars are burning through hydrogen, that kind of thing. But when it comes to a supernova, you're actually looking at all the elements pretty much, because a supernova, that's where your elements that are heavier than iron form. You know, what causes a supernova is a massive star. Once it's burned through its hydrogen and helium and carbon and things like that, it ends up getting to iron. And just a quirk of nuclear physics, the iron doesn't behave the same way under the fusion settings. Under the fusion reaction within the star. And so once that iron starts building up in the core, the star essentially blows out. You know, it implodes and then explodes. And so, but when that happens, all that energy creates all of those other elements, you know, up from iron. So getting up into your levels of plutonium and things like that. But, you know, gold, those kinds of elements all get created at that instant that the star explodes, which is cool, in my opinion. But the other cool thing, and the reason why I want to look at the Crab Nebula, and I'll be looking at this in more detail later on with on another night with a little bit higher powered telescope that I've got, is one of the reasons why this looks so small is this is a new supernova, relatively new. This exploded within the last several thousand years. And we know this because there were records of it when it happened. I mean, this is something that Chinese astronomers noticed at the time. They noticed that supernova happened. It was, you know, so bright it was almost like another sun in the sky for a few weeks when it happened. And, you know, so we knew that because they tracked where it was in the sky, and later on when we looked at it, we saw this here, right? As you can see, as it's been coming in, we're getting more detail in there. It's starting to come out a little bit more and more. We probably won't get too much in here, but, you know, what is extra cool about this, like I said, it's small, and it's an explosion that happened, and everything is moving out, right? Everything continually is expanding on that ball of that explosive ball of gas that came out. NASA actually, you know, we've been taking photos of this ever since we started taking photos of deep sky objects, right? NASA actually has, if you look online, there's a video that they put together of, I think it's the last 30 years of photos of the Crab Nebula. And the really interesting thing about it is that you can watch how this has changed. You know, a lot of times we don't think of the night sky as changing that much, other than maybe the planets moving or the moon moving. But this sucker's actually, it's close enough and it's young enough that this gas isn't spread out over 30 or 100 light years, right? This is at most like a light year or so across. So, you know, you can watch effectively over the span of your lifetime this thing change. Now, luckily, I don't have to wait 40 years to do it. NASA's been doing it for us, so that's something I think is really cool. Is that, you know, this is a star that blew up pretty close to us, and recently enough that we know about it. And NASA's actually been putting together video of how it's been changing, which in my mind is one of the cooler things out there. So we're not going to spend a lot of time on it outside of that, other than I just thought it was a neat thing to take a look at. And let's see if we can end things with a particular target here. Not sure if we're going to hit it without having to once again reset things. Chances are we're probably off by quite a bit here, but let's take a look. Yeah, I think we're probably off. So let's go ahead and do our quick snap too. So what I'm looking for is our last target for real is going to be, sorry, where was it? Is the Rosette nebula. Go. And would you please center that for me? Nope, because you haven't connected your camera yet, idiot. There we go. Now would you center it for me? Why, yes, I'd be happy to. So the Rosette Nebula, as you may have seen in that preview there, is also just a really gorgeous nebula. It's a little bit bigger than what I can get fully in my camera here, but we should be able to get at least some of it here in a way to at least get a look at it. It may be a little washed out by the moon, but we're going to give it a shot for just a few minutes here. And then we'll close it out for the night because we've been going for about an hour and a half at that, or I'm sorry, about 2.5 hours at that point, which isn't too bad. All right, 11 pixels off my center. I'll forgive you. All right. So let's get back in here. And we'll let this run at its 15 seconds, and we'll see what we get. All right, well, that doesn't look like much yet. All right, 2 frames in. Let's get to our third before we zoom it in. All right. Hello. All right. So let's give this a few more frames to, as you can see, we've got that moon glow coming back through here again. There we go. All right, let's let this run for a couple minutes here. But already you can see our shape of the Rosette. Now, the shame is, when you really don't have, the excessive kind of moon glow going on and all that kind of thing, you really get a lot more kind of detail coming through. but we'll see what we can get here over a couple of minutes. All right, so coming back here, we got a lot of detail in here for the fact that it's very washed out with sky glow, right? But once again, we're about 6 minutes in on the stacks there, and looking at this, you can see kind of what I call like the little bit of lightning bolting going on, through here. But really, what others would say makes up the petals of the Rosette Nebula here, right there. Bring it out a little bit more so you can start to see some of the detail coming in around here and that kind of thing. Unfortunately, once again, that moon is just way up on us. But yeah. So that is your Rosette Nebula, which say that I would take a picture of it. It doesn't seem to want to let me. I'm not sure why. But I think that will do it for us for tonight. So, I'll leave you with hopefully a picture that looks a little bit better, this is once again the moon that I took last night. So, the one that we took tonight I think may actually turn out even better than this one. So, not too unhappy about that. I hope for anyone that watched this either live or after the fact that you had a good time with this. Maybe you learned something. Maybe you learned some things that you can share with me about what not to do in the future, that kind of thing. But importantly, let me know if this was fun, if this was something that you'd like for me to do again in the future. If so, I'd be happy to do it. I did really enjoy kind of doing this kind of stuff. It's fun to set up a very detailed plan for an evening and let it run all night long. But sometimes it's really fun to just, take the stuff out and see what you can see by looking around. I really enjoy that kind of exploration part of the hobby. Hopefully you do too. So drop me a comment, let me know what you thought about this and if you'd like me to do this kind of stuff in the future. But with that, I think we'll call it an evening. So thank you very much for watching. And let me know if you'd like to see this in the future. And clear skies.